Hi, my name is Kaleigh G OW, and I'm a junior here at Frisco High School. I'm in the FHS band, and I play French horn. I'm also in the Greater Dallas Youth Orchestra. Music is one of my passions, along with science and academics. I first became interested in genetics as a freshman in biology. It was one of my favorite units. It just fascinated me that everyone was different, yet we all had such similarities in our genes. And my quote for this year was, "At bottom, every man knows well enough that he is a unique being, only once on this earth. And by no extraordinary chance will such a marvelously picturesque piece of diversity and unity as he is ever be put together a second time." And that was by Friedrich Nietzsche. And this quote means to me that everyone is unique because we all have like a different set of genes and DNA, yet we're all so similar because we share a lot of the same DNA at the same time. What is genetics? Genetics is the study of heredity and variation of inherited characteristics, which pretty much just means that we all inherit our genes from our family. And genetics is based off of the cells in our body. You can see from the image that we all have cells, and inside the cells is the nucleus, which controls the cells. It's like the brain. And inside the nucleus we have chromosomes. There's 21 of them. And inside chromosomes we have DNA, and the DNA make up our genes. One of the big parts of genetics is genotype versus phenotype. Genotype is what's in your genes versus phenotype is what shows up in you as a person, like what people can see. How is genetics used? It's mostly used in diagnosis and early detection. So we can currently test people for certain diseases, and depending on what that test shows, we can detect whether or not they're going to get the disease, at what age, and its severity. It's also used for in vitro fertilization, or IVF. We use genetics to be able to predict what diseases a mother is going to pass on to their child, and through this we can alter that to be able to help the child. And genetic counseling, that goes hand in hand with in vitro fertilization. That just means that we talk to the parents and are able to predict the possibility of their child having a disease. My research for this year, these are just all of the different research assessments that I've done so far. My very first one was on predicting diseases because that was something I'd read about in newspapers and on the news. Predicting diseases, it fascinated me that we can tell like what diseases you're gonna get when you're like 50. That was just crazy to me. Like if we were to sequence someone's genome, we could tell you like if you're gonna get breast cancer and what age, and not everyone wants to know that, obviously, and for the most part it's illegal, but we can still predict that if you really wanted to know. Designer babies, there's actually a clinic in Frisco that you can like choose your baby's eye color and their gender, and I think they're working on hair color. So it's pretty controversial, and they've actually been asked to stop because people think that it's like playing God. That's a matter of opinion, and in medical ethics, a lot of people actually study that. Huntington's disease, this is a disease that I talked a lot about with my mentor. It's basically a disease in your brain. It's highly degenerative, and you usually die by the age of 40. So I wanted to learn more about what causes that and its symptoms. Breast cancer detection, this was just studying the variants in your genes that cause breast cancer and being able to predict your probability of getting breast cancer. Prenatal sequencing, this was an article that talked about a man who sequenced his baby's entire genome before he was even born. Thankfully, there was nothing wrong with him, but if there had been, that child would have had to live with the knowledge that he was going to come down with some disease when he was like 50, and he would have known this when he was like 3. So that was pretty controversial, and a lot of people were mad that he did that. But it also shows that this is going to become more and more common in the future. Gene therapy, this was really interesting to me. Gene therapy is where you insert a virus into someone's genes, and the virus has an ability to change the genes to like inactivate certain things to make you more or less susceptible to a disease. Jesse Gelsinger was one of the first people who tried it. He actually ended up dying at the age of 18, and gene therapy is not as popular as it used to be, but people are doing more research, and hopefully it will become more popular again. My interviews, this year I did 5 interviews with different geneticists in UT Southwestern. My first one was with Dr. Angela Shirley. She studies clinical genetics and pediatrics. She was a mentor previously and studies a lot about fertility drugs and their side effects. Dr. Ralph Debradinis is the head of the lab at UT Southwestern, which I thought was really amazing that I got the opportunity to be able to talk to someone who was so high up in the career ladder. He also studies pediatrics and geneticists and genetics, and is also a physician. Dr. Helen Hobbs focused more on lab work than in the clinic, which I didn't think I would be interested in, but once I got to tour the lab there, I found that it was really cool. You could see where they were doing the electrophoresis that we learned about as a freshman in biology. They actually still do that. And she works on identifying genetic variations that counter susceptibility to fatty liver disease. That was one of her newest discoveries. Dr. Louis Amanya also works at UT Southwestern. He graduated from Baylor, and he's actually from Columbia, which was really interesting that people of such varying backgrounds come to UT Southwestern just to work in their genetics department. I've since seen him multiple times at my mentor visits, so it's nice to reconnect with those people. We talked a lot about gene therapy, which is where I became interested in the case of Jesse Gelsinger. Dr. Mary Lynn Mann is a fellow at UT Southwestern. She's currently an OBGYN and is working to become a geneticist. She is much younger than everyone else, which I liked about her because she is a lot easier to connect with, and she's really good at explaining things. My original work for this year, I decided to focus on newborn screening. This is something I talked a lot about with my mentor. And newborn screening is basically where they test babies for diseases that are probably fatal but can be treated easily if they're caught early enough. A lot of the diseases that they test for are fatal unless they're caught early enough. Sorry, I already said that. Diseases that they usually screen for include PKU, cystic fibrosis, congenital hypothyroidism, and maple syrup urine disease. In Texas, we screen for 39. In California, they screen for 56. So Texas is kind of behind the 8 ball on that. But they're working to expand the diseases that we screen for to be more thorough. For my original work, I researched the diseases that we do screen for and also what we can add to the test to see if there are any more diseases that would be helpful to know about in newborns. So I wanted to make a pamphlet for new parents to be able to educate them on what their babies are being screened for. The diseases I tested for were right here. I'm not going to name them all. They're really complicated, but they're all basically preventable if they're caught early enough. So this is my finished product for my original work. I'll pass it around. In the pamphlet, it's educating new parents on newborn screening and why it's important. Newborn screening is required in the US unless it goes against your religion. But for the most part, it's a really good idea to invest in. It's completely free for parents, and we pay for it with our tax dollars. There's a picture of my finished product of my original work. And my mentorship. Lately I've been visiting the genetics clinic at Children's Hospital in downtown Dallas. I've gotten to see 6 patients so far. One of them had glycogen storage disease, and this is a disorder where you can't process glycogen. So the little girl that had it, she had a G-spot, which is like a button on your stomach where you can receive food from, because she had a lot of problems eating. She's also supposed to drink cornstarch because it helps with the storage of glycogen. Unfortunately, she wasn't following her doctor's rules very well, so she was struggling with her health a little bit. I actually got to feel her liver through her stomach, and it was really enlarged. It actually felt almost like a rib, which was kind of surprising. And Lesch-Nyhan syndrome, this is the second child that I saw. It was a little boy, he was 7. Lesch-Nyhan syndrome is a really devastating disease. Children with Lesch-Nyhan syndrome have an imbalance in their brain where they are prone to self-mutilation. So this little boy, when I first met him, I thought he had a cleft palate, and as it turned out, he had actually bitten his lip off completely, and they had to re-sew it together, which was really sad. I didn't realize that when I was talking to him. They also have muscle spasticity, like people with cerebral palsy. So he had been diagnosed with that for 6 years, and he had just recently received the diagnosis of Lesch-Nyhan syndrome. Children with this disease also are prone to completely biting their fingers off. And it's not that they can't feel pain, it's just that they can't stop themselves, which is really devastating to their family members. Angelman syndrome was another child that I met. This disease is often called happy puppet syndrome because the children often never learn how to talk. They walk around with their hands curled in fists, like by their faces, and they smile all the time. It was the cutest kid. I think he was 7 months, and he just constantly smiled. But the doctor I was working with at the time told the mother that that was a symptom of the disease, which I had no idea. I didn't know that I thought it was just a behavioral thing, but it's actually a symptom. And Beckwith-Wiedemann, this was the child that I met on Monday over the break. This disease makes you, one side of your body is bigger than the other. So one of her cheeks was really big, and then the other was normal sized. And then some of her fingers were really swollen, which was really sad, but it doesn't affect the brain. And these children usually grow up to be pretty normal. So that was good to hear. One of the interesting things about my mentorship so far, a lot of the people that I've been working with don't speak English. So we have to speak through an interpreter, which is a different experience. I don't speak any Spanish at all, and a lot of the parents that we meet speak Spanish, so I think it'd be nice to know how to speak Spanish. My mentor did a consultation with a couple who spoke only Arabic, and it was 3 hours long. So that's just an example of the day-to-day life of a geneticist. They have to work really hard just to communicate with their patients oftentimes. And this is a picture of me and my mentor on Monday. And my conclusion, in ISM, I hope to gain hands-on experience in the field of genetics, and I'm hoping that that will help me decide on my college major. While I'm not sure if I want to do genetics in college, I now know that I definitely want to do something in medicine because I love to help people, and helping children that are sick is definitely a passion of mine. Through ISM, I also hope to gain experience in professionalism and interviewing. And in the future, I'm hoping to double major in college in music and biology. And ISM is helping me to narrow down my college choices. Right now I'm looking at SMU and maybe Rice, maybe Northwestern. So we'll see. Through ISM, I'm really enjoying myself and can't wait to see the future. Thank you, and that's it. Oh my God, that was